Hi YouTube, welcome back again to my channel, and for today's video, we will be talking about answering some problems in group theory. So we will start now. Okay, so let's start now. We will start answering this true or false question. So it says here that we say it's true if the statement is true, and we say it's false if the statement is false, and we will provide either with a proof or a counter example or an example or an explanation to it. So number one, in a given group, the identity is always unique. So this is true. In fact, this is one of the fundamental result for the group theory. So always unique siya. So ibig sabihin, if you have an A in G, then A asterisk E, if this is the binary operation associated to G, so that will be ganyan. So you can no longer find any other E that will satisfy this equation. So therefore, it's unique. Number two, let S be a group of permutations, then S is a billion. In fact, a group of permutations is not a billion. So ibig sabihin, let's say if S is together with the binary operation, which is this one, let's say for example, you have ganito, 1, 2, 3, 1, 3, 2. So if you multiply that with a permutation of 2, 1, 3, you cannot, the result is not the same if you swap the places. Kasi sige nga, we'll double check. So this is 3, this is 1, and this is 2. So we'll see if that's the same. So swap ko yung places nila. So I have ganito, 1, 2, 3. So this is 2, 3, and 1. So hindi sila equal. So therefore, this is false. How about number 3? Let F be a homomorphism of groups from G to H, then the range is always equal to its codomain. No, we're only talking it as homomorphism. We're not calling it as epimorphism. Yung epimorphism kasi, so ibig sabihin yung homomorphism siya and it's on 2 at the same time. So when it is on 2, yung range at codomain mo equal. Ang sabi lang kasi dito, it's homomorphism lang. So therefore, this is false. Number 4, let F be an isomorphism of groups from G to H. So then the range is always equal to its codomain. In fact, when we say it's isomorphism, so ibig sabihin it's epi and it's mono. So therefore it's epi. So it's epi, that means it's onto function. So dahil onto siya, ibig sabihin nag-i-equal yung codomain at range. So this is true. Number 5, give an automorphism of groups G given, okay, sorry, the domain and the codomain are equal. Automorphism kasi siya eh. So we can only state an automorphism like F from G to G. So pareho sila. So this is true. Number 6, a homomorphism holds true whenever the kernel contains only the identity element. Meron result tayo regarding on the fact that if the kernel EG is equal to EH, then F is a homomorphism. However, the converse is not true. So therefore, this is not true. Kasi pa-converse dapat to eh. Okay, number 7. Given an isomorphism F from G to H and a homomorphism G to H to G, we have this. Actually, this is one of the famous result. So, ibig sabihin yan, sorry, hindi dapat to G. Sorry, F inverse yan. So, ibig sabihin yan, pag ganon, maging identity pa rin yan. So, that is true. And number 8, we can say 0, 3 is a subgroup of Z6 under addition modulo 6. Yeah, because di ba kung titingnan mo, ang 0, 3, so it's addition modulo 6. The inverse of 3 is 3 itself. So may inverse siya. Yung identity niya is the 0. It's associative. And then, it's close under the operation. So therefore, it's true. A set Q along with the usual multiplication is a group. Sorry, ang daming typo error pala nito. This is not a group because 0 is an element of Q and it doesn't have an inverse. So therefore it's kasi bakit ba may inverse? Kasi ang problema kasi natin dapat, 'di ba, for Q kasi yung identity element niya sana is 1. But 0, 1, it's still 0. So there's no way we can make it as 1. So therefore, it's not true. It's false. Walang inverse is 0. Number 10, a subgroup inherits the property of associativity of a group containing the given group subgroup. Nasa rule kasi in the fundamental of math that a subset always inherits the rule of the superset. Yung group natin dito is the superset. And then the subgroup, nag-i-inherit din siya dun. So this is true. Okay, for the multiple choice, which of the following is not a property of monoid? Monoid siya, so ibig sabihin, semi-group na siya. So ibig sabihin, meron na siyang identity. So the identity is unique. So it's an identity, it's a property of a monoid. However, it doesn't have an inverse yet kasi monoid pa naman siya eh. So therefore, this one is not a property. Pero I think there is another one. Yung left and right cancellation mo, mag-holds yan, which is true for monoid. Kasi ang mangyayari kasi doon, let's say AB dyan, if that is CB, makaka-cancel yan. So it's AC. That's one of the properties of monoid. However, yung inverse of the product is always to the product of the inverse. So, ibig sabihin ba, if you have, let's say, AB inverse, that's equal to A inverse, B inverse, hindi siya commutative in that case, in that sense. So, therefore, the B and the D is the answer. Number 2, which of the following is not true about a group? All groups are vector spaces. Alam natin yan. And all groups are metric spaces. All groups are topological spaces. However, all groups cannot generate topological spaces. So that's number 2. Okay, number 3. Let H1, H2 be subgroups of G. Which of the following is not true? Tingnan natin dito kung subgroup siya. Kunin muna natin yung, kasi duda ako for letter C, it's subgroup eh. Kasi isipin mo yung AHA inverse mo. Yung A kasi is galing sa G. So, note that H is an element of H, di ba? So, since G is a group, ibig sabihin pwede E exists in G. So, you can write EH A inverse. And that's an element of AH A inverse. So, therefore, hindi siya empty. Pangalawa, this is obviously a subset of G. Yes. And then pangatlo, let's say meron kang X and Y in AHA inverse. So mangyayari niyan, X is equal to AH1, A1 inverse, and then your Y is AH2, A1 inverse, A inverse. So ang mangyayari dyan, X, Y inverse. So meron kang AHA inverse, AH2, 1 yan, A inverse, may inverse pa dyan. So, ang mangyayari dito, ano ba? This is AHA inverse. Ito yung mauuna para maging inverse na meron kang A, H2 inverse, and then A inverse. So, yan, magiging identity yan. So, you'll have A, H1, H2 inverse, A inverse. So, ano to? Di ba this is just the same as this H? So, element siya ni AH, A inverse. So, therefore, it's a subgroup. For ano pa, this is obviously a subgroup eh. Kasi a famous result naman to eh. So, let's say, X is an element of A intersection H2. So, let's say, meron ka pang Y. So, yan. So, X, Y inverse. Ang mangyayari dyan, this is papasok pa rin dyan sa banga. Okay, for letter A, hindi yung union. So, therefore, it's not a subgroup of G. Okay, number 4. Which of the following is not true about groups and subgroups? So, a group of all permutations, denoted by Sn, is the set of permutations that leave and fixed forms a subgroup isomorphic to S n minus 1. In fact, this is one of the properties of a permutation group. So obviously, this is true. Ang letter B naman, if n is a fixed integer, then nz is a subgroup. This is obviously true. And then ZP has no other subgroups except the set containing an identity or itself if P is prime. So it's a famous result kasi pag prime kasi si P, so ibig sabihin wala siyang ibang subgroup maliban sa sarili niya at yung trivial. So ibig sabihin yung trivial na yung ilang ang lumalabas, nasa loob pala. So this is not true kasi 5 is a prime eh. Tapos ayun no. That's not either Z5 or the trivial. Number 5, which of the following is true about cosets and countings? So the number of left cosets is always the same as the number of right cosets. If the right and left cosets coincide, there always exists a non-abelian groups and subgroups. And then there always exist non-abelian groups and subgroups such that right and left congruent coincide. So this is the only true here. Kasi iisipin mo, okay sana, hindi kasi ito if and only if eh. Kasi sabi lang doon, there always exists in non-abelian groups and subgroups for some, parang ganon. If, I mean, whenever, something like that. And so, letter A yung sagot natin. Okay, tapos na tayo for multiple choice. So, we will answer this one. So, when can we say that a set G together with a binary operation is a group? So, paano ba? We say that G together with the binary operation asterisk is a group if, of course, G is not empty and number 1, the binary operation is associative. So yung asterisk mo is associative yan. Number 2, there exists an identity E in G such that E is equal to A, which is equal to A. This holds for all element in G. And number 3, for every element in G, there always exists an inverse A inverse in G such that yung binary operation nila together will result to identity. That's it. Okay. So for letter B, is Z together with the usual addition a group? Why or why not? Okay, so check natin. So, paano ba? Associative. So let A, B, C element of Z. So close naman to eh because the sum of two integer is always integer, so it's close. Obviously, Z is close under addition. And then close siya under addition, so it's also close. Or I mean, it also holds for associativity. A plus B, yan, plus C is equal to A plus B plus C. Alam naman natin yan lahat. That is obvious. Kasi nga, kunyari, ito, scratch muna tayo. 5 plus 4 plus 3. So that's the same as 5 plus 4 plus 3. Pareho lang ng result. Okay. Yung identity, as isabihin ko na lang ha, yung identity naman ng Z is addition kasi siya, so 0. So you always add any non-zero integer with 0, the result is that integer. So therefore, 0 is the identity and so it exists in Z. So dahil identity siya, so we will be looking all the possible numbers in such a way that the sum of the other pair is 0. So ibig sabihin ko, makikita mo naman na may inverse talaga yung mga integer. Kasi let's say, 1. So ibig sabihin yung inverse is negative 1. So if you add them together, you get 0, which is the identity. So therefore, Z is a group. Okay, for number 2, letter A, show that a non-empty subset H of a group G is a subgroup if and only if for every xy in H, xy inverse is in H. So, how do we show that? So, if H is a subgroup of G, so ibig sabihin forward direction muna tayo. Ayan. Anong ibig sabihin dan? Yan. Then, for every A, B in H, alam natin B inverse is in H. And so, AB inverse is in H since H is close. Okay, kasi bakit close? Because H is a subgroup of G. Okay, how about the backward direction? So forward pa yung sinold natin, yung backward naman. So we will assume that XY inverse is in H for every X and Y in H. Okay, so mangyayari dito, since H is not empty, alam natin yan, there exists A in H so that E is equal to A, paano ba? Yung E is equal to A inverse, which is an element of H. So, anong kasunod nito? So, ibig sabihin nito, you can write as A. So, ibig sabihin nito, you can write as EEH. So, nag-i-imply ito na, so this is for any in H, nag-i-imply ito na magiging B inverse is equal to EB inverse. Okay, so anong implication? So, let tayo ng AB in H. So, di ba BE inverse is in H? So that yung AB mo is equal to A, B inverse inverse. Di ba pwede natin i-write yan? Which is an element of H. Okay, kasi alam naman natin element siya eh. Okay. So, the closure holds for H. And associativity actually automatically follows since G is a group naman. That's it. So, draft lang tong ginawa ko guys ha, kayo na bahala. In fact, this one theorem here is actually a subgroup criterion. So, ibig sabihin parang isa to sa mga sikat na discussion. So, that theorem will be used to double check if our anong mangyayari if our given group is actually a subgroup of the other. Okay, question number letter B. F is a mapping from G to H, be a homomorphism of groups G and H. So show that the kernel of F is a subgroup of G. So how do we show this? Sige nga. Paano? Letter B. So proof. Since F is homo, di ba F of E, G is equal to EH? So, anong ibig sabihin nito? Drop lang to. Implication is EG is in the kernel of F. Yan. So, therefore, the kernel of F is not empty. Alam natin na meron talaga siyang laman. Okay. So, how do we do this? So, let X and Y in kernel of F. Okay. So, mangyayari dito, that's F of X is equal to E sub H and F of Y is equal to E sub H as well. Okay, this holds for an arbitrary X and Y coming from the kernel of F. So, di ba pwedeng ito? X, Y inverse. Di ba alam natin this is F of X, F of Y, since F is homo. Okay, so this is F of X times, di ba yung inverse lalabas yan kasi homomorphism naman si Y. So instead of writing that, ganito na lang. Okay. So dahil si F of X is andun kay H, is equal to E sub H. So ibig sabihin, this is equal to E sub H times E sub H inverse, which is equal to E sub H. So ibig sabihin, yung XY inverse mo din pala is an element of the kernel. And therefore, by the power of the subgroup criterion we have discussed earlier, asan yun, yung letter A, ibig sabihin, ito is a subgroup. That's it. Okay, for letter C, let F be a mapping from G to H be a homomorphism of groups G and H. So we will show that the image of F is a subgroup of H. So paano natin yan gagawin? How do we establish the proof? Since ganito na lang, let's reconstruct this muna. So pwede natin gawin yung F of A subgroup ni H. So bale si A natin is a subgroup of G. Okay. So, since yung A natin is a subgroup of G, anong mangyayari? A is not empty. Yan. So, F of A is also not empty. Okay. So, let A be in F of A. Yan. So, anong implication yan? Then, there exists paano ba? Let's say A bar, B bar in A such that ang mangyayari F of A bar is equal to A and F of B bar is equal to B. Okay. Since ano pala, yung A mo is subgroup of G, so ibig sabihin, etong mga to, A bar, B bar, yung product nila is in A. Okay? And so, f of A bar B bar, mangyayari, this is equal to f of A bar f of B bar. Kasi, di ba, f is homomorphism. So, lagay ko dito, since f is homomorphism. Yan. And so, this is equal to A, B, which is an element of f of A. So, therefore, yung f of A mo is a subgroup of H. That's it. So if you have any questions or clarification, please let me know so that we can discuss on that. Okay, that's all for today. Thank you so much for watching. If you have any questions or clarification, please let me know so that we can discuss on that. And for those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. Thank you and have a great day.